Hello there, recording. I forgot to start it with recording though. We're looking at the factoring set of examples. We went over what a linear is, a quadratic, a cubic, and quartic is power 4. That depends on the degree. Make sure you know that. We reviewed how to use a difference of squares. We also played around with what a difference of cubes or a sum of cubes might be. There are formulas for other powers, but we won't come across them too often. You'd be given those for sure. We looked at an example of a difference of squares that was kind of simple. Then we looked at an example of a difference of squares where you might have to do some work afterwards. That's this one here. Oh, this one here. And so on. We had to group like terms after. Then we did a difference of cubes example. This is the cube root of 125x cubed, cube root of 27. If we match it up, it's like my a term squared, a times b squared. Stop and take a look at those. Lastly, we factored this expression, taking out the common number, 5. The lowest degree on the variable, because everything had an x in it, the lowest degree is -5 halves. Once we do this, we saw that the bracket we could factor further. We're now on example 18. And here I see x and y with both of them. So I'm thinking, I'm going to just color code something here. I'll rewrite it. X to the 5/3, y to the -1/3, subtract, x to the -1/3, y to the 5/3. Now, does this look familiar at all? It doesn't look like a cube or a squares or anything. But we do have an x in each one and a y in each one, so we can take those out, right? So, as far as x is concerned, I can take out the lowest degree, which is, it's obvious here, it's the -1/3. The common term for y's, the -1/3 as well. It's the smaller of the 2 degrees. Now, what do I get left behind? Now, remember, anytime we're dividing out with fraction exponents or any exponent, you can think of it as subtraction. So what I'm doing is I'm thinking 5 out of 3 subtract negative, so I'm really adding 1/3. So 5/3 plus 1/3 to come up with my x to the, well, 5/3 plus 1/3 is 6/3, 2. This is an exact match, so it's a 1. We don't need to write anything down. Lessons. That's an exact match, so the x disappears. It's 1, x to the 0. 5/3 minus negative, hey, this is a repeat of the arithmetic we did before. So adding 1/3, 6/3, 2. Now I do recognize a difference of squares, I hope you do anyways. Right, x squared minus y squared, x plus, x minus, y. We keep the front numbers though. And I'm going to just drop the whole color scheme now, I think. You guys would have seen that. It doesn't matter if you put x minus y, x plus y in that order. Lastly, factor over the set of rationals. Look, the gravy. We've got 2 cubed minus 18. Looks like the x cubed minus something reminds me of a difference of cubes formula. I'm not convinced yet. When you factor, though, you can make your life a lot easier if you get rid of fractions. In a sense, think of what could I multiply this whole bracket by to get rid of the out of 3? Times it by 3. So here's what I'm thinking. I'll show it. I'm thinking like this. 3. I'm going to do this carefully. Out of 3. Now, this is a thinking step, so you don't necessarily have to write it out like this, unless it really helps you. But what I'm thinking is, have I changed anything here? Because when you factor, you can't change the equation. I'm really multiplying by 1. What good does that do me, though? Well, it gets rid of this fraction, because then I could think I got to distribute. 3 times 2 divided by 3. Well, 3's canceled, don't they? And I have to think it through with 3 times 18 as well. I have to distribute what I'm doing. But does that make some sense? Okay. So that's what I'm thinking. And if you need to show that, that's, oh, keep grabbing the wrong things. That's something you want to show, go ahead. There's no problem with that. If you skip straight to 1/3, though, I'll believe you, and you multiply in your head. 2/3 times 3 cancels the 3's. I've got 2x cubed minus, good gravy here, 3 times 18, 54. Now, I did it one thing at a time. You're going to find out, well, I could have taken out 2/3 right away. You can. Sometimes, though, and I wanted to show it this way, sometimes it just doesn't work out that way, the numerators. Now, I could take out the 2 right away, or I'm taking it out as a second step here. But we've got a common factor of 2. 54 and a half is 27. So you could have done it that way, right off the bat as well. I suggest, though, taking the time to do the denominator first. Sometimes it turns out another way. So x cubed minus 27. Hey, that's a difference with cubes in it. Oh, gravy. I'm going to pull that one of them down, though. Now, a cubed minus b cubed. My a is like the letter x, my b is like 27. So 2/3 x minus 3, a squared is like x squared, plus a times b is 3x, 3 times the x, plus 9. I'm trying to erase that tick mark there. There we go. Now that's a big one. Now, depending on how... Oh, here? Or this is a square, this is a cubed minus b cubed. Shows up fuzzy on your paper?
Yeah. Or whatever.
It's a fuzzy on here for sure. Yeah, nope. Be sure, that's the best thing. Ounce of prevention is worth a pound of the cure. Now, we have several ways of going about this one. But I would suggest getting rid of the fraction first. What could you multiply through over 6, over 12, and over 2 to get rid of all of those? Yep. Is there one number that you could multiply through this expression that would get rid of all of the denominators, canceling out? Well, if I multiplied everything by 2, it would only get rid of the out of 2. If I multiplied everything by 12, well, we'd have 12 over 6. That would work. Get rid of the 6. Definitely get rid of the 12. And 12 over 2 is 6. It would get rid of the denominators. So really, I'm thinking here, and I'll do it in disappearing ink, I'm going to go with 12 over 12 is what I'm thinking, multiplied through this expression. I'll have 1 out of 12 outside. Everybody clear on that? Maybe I'll even write it down. There's no reason why. This is what I'm thinking. I wouldn't necessarily expect you to write this out every time, but if I now pull the 12 through, distribute it, multiply everything by 12, what do I get? So typically a student would start at this step. 1 out of 12. Then, in your head, you think 5 out of 6 times 12. Just a second. Let's move this down a bit. So what I'm thinking is 12 times 5 out of 6. What do you do with the 12 and the 6? Before you multiply, I would not go 12 times 5 is 60 divided by 6, although you can. I'd usually simplify ahead of time and just say, well, 12 and 6, that's a 2. And then 2 times 5 is 10. 60 divided by 6 works, though, but sometimes you get numbers so large. It's a nightmare. What about this one here? Well, 12 times 11 divided by 12. Hope you see that right off the bat. You're just left with the 11. Lastly, 12 times the minus 1/2 minus 6. Sorry, is there another one? Okay. And you're thinking, what now? Can I factor this one further? You can. There's a number of ways to factor these. Some people just see them thinking, okay, 10x times 1x at the front, or is it 5 and 2? And then they just kind of think it through like that. And that's good. And actually, I suggest if you do it that way fast, that's great. I'm going to show decomposition though. Because it always works. Well, all of them always work, but sometimes people find that. You ever do this? Say what makes negative 60 multiplies to negative 60 and adds up to 11. So it'll be a positive and a negative. 60. And has a difference of 11. So definitely not 1 times 60. Definitely not 2 times 30. 3 times 20. Nope, the difference is 17. 4 times 15. Hey, the difference is 11. That works. Okay. Now, I decompose the middle term. I purposefully left that out. So what I'm thinking is I'm turning that 11 into, which is the positive, which is the negative? Well, 15 and 4. I need more positives because it adds up to positive 11x. So 15x minus 4x. You guys have done it this way. You might be rusty on it. That's why we're reminding each other how to do it. By the way, I make mistakes, and they're not so that you can correct me. I make mistakes because I make mistakes. So stop me when I do. Ask me if something doesn't make sense. So now I look at the front 2 terms. I'm going to start with the square bracket here. Only because you don't need to use square bracket. Between 10x squared and 15x, I look at the first 2 terms. The number 5, definitely available, and the letter x is in common. So 5x out of the first 2 terms gives me 2x plus 3. Subtract. If there is, when you're factoring like this, if there is a minus sign on the front term, you always take it out. Okay? Even if it's just minus x, you say, well, minus 1 is what I'm taking out. Now, the 4 doesn't work in both, but 2 does. The x can't come out of both, so I'm just going with minus 2. Now, that turns into 2x minus, no, plus. Taking out negative 2. Messy. 3 plus 3. Now, did I make any mistakes? Chances are you didn't if you do decomposition and you have matching brackets. What's in common with both of those? 2x plus 3. You take that out. What are you left with? So 2x plus 3 is what's in common. What I'm left with is 5x and subtract 2. Like I said off the start though, if you're good with these another way, you say, well, 10x could either be 1x times 10x or 5x times 2x, and then you just dream up and do some quick arithmetic in your head and see what works. Go ahead and do it that way. I won't coach you on that right now. Some people catch on to that right. Okay? Now, questions for you? Where did I put that recorder though?